I realized we're a little late, but I saw people coming in with pizza, and nobody came in. Kelman? I thought, where's the love, man? I know, I gotta talk, so. Thanks for coming to the last talk of the day before the party, and I thought the pizza would be later. With my luck, there'll be no pizza when I'm done. Anyway, if you want to know who I am, read the slide. Dr. Phil. I teach over at Bloomsburg University of Pennsylvania. People say, where's that? It's in Bloomsburg, Pennsylvania. But, about 70 miles northwest of Philly if you flew there, or 2 hours if you drive. All right, I want to talk a little bit today about some fun with remote hacking drones. Some of you may have been here last year, may have heard a talk that I gave. This talk is kind of going to be an extension of that talk, so I'm going to briefly review some of the things I talked about, or for Kelman, about last year, to give you some context, and then we're going to talk a little bit about how you can automate some of these attacks using Python and such. I did want to point out over there on the table, I just set out some of my toys. Feel free to go look at them, touch them, but don't molest them too much, break them. That's what the TSA does to me. I went to Belgium a couple weeks ago. They broke stuff on the way there, broke stuff on the way back. So that kind of sucks. All right. I won't be offended if you go over there and play. Why should you care about any of this stuff anyway? I'm going to talk a little bit about a nice full-featured Linux install that you can have on some small devices. They're low power. You can run them for days on battery or indefinitely on solar. They're nice and small. You can plan them. You can network them together, which is where you get the real power. Also, you can throw them on an aerial drone, right? So you can use that for some initial recon. Maybe you don't have good physical access to your target. You can fly in with this. If you really don't have any access, you can orbit for a bit, collect some data. And ideally, you might be able to land it on the roof. Try not to crash. If you do crash, you can always play stupid. You know, I was talking to someone last night about, you know, when you're traveling, say in Europe, and you're on the train, and you do something wrong, right? Like you don't pay what you should pay for a ticket or things like that. You can always pull the dumb American card, like, oh, I just don't, it doesn't work like this in the U.S. You know, you do the same thing. Oh, yeah, I was flying my drone, my airplane, my RC airplane, and it kind of crashed on your roof. Can I come get it, please? So talk a little bit about that, but I want to focus on some other things. A little bit about me. I'm a professor at Bloomsburg University. As I just said, I've been programming since age 8, hacking hardware since I was 12. I've also been known to fly and build airplanes. And little plug, I also wrote a book, which is available for sale. I have a couple copies even. More about that later. So what we're going to talk about. I'm going to talk just very briefly about this early stuff, choosing a hacking platform, some possible aircraft you might use for an aerial drone, a little bit about the deck, which is my pen testing distro, talk about what you can do with one device running the deck, and then we'll get into the real fun stuff. What can you do if you start adding these guys together in a nice mesh network? A little bit about building hardware, what that looks like, a couple of scenarios, and then we're going to end up talking about how you can use some pretty simple Python in order to make this better, a little bit more automated. So when I was going to choose a hacking platform, I really wanted something small, low power, cheap, something mature that's not going to crash all the time, with good networking, USB support, and such. And of course, I chose BeagleBone Black. Originally, I started this work, some of you might know, on the BeagleBoard XM, and then the BeagleBone Black came out, and it was about the same power, a third of the price, so kind of went with that. They're pretty cheap. They have enough memory, and most importantly, they don't use a lot of power. The board itself uses less than 2 watts. You can have a whole system for about 10 watts. Lots of GPIO if you need it. Just a fun little board to play with. Also very stable. So, looks like this. BeagleBone Black, also known as the Raspberry Pi Killer. I know somebody said earlier today, who doesn't like Pi? Well, it's not the good Pi. Right. You know, someone always asks me, why don't you use the Raspberry Pi? Here's a partial list of reasons not to use it. If you want a fuller list, it's in a book that I may have mentioned earlier. Okay. So for the aircraft, for aerial drones, my criteria for that, I wanted something with a good payload. You know, I can lift a device or two. Something you can fly in the wind. A lot of the cheap toy drones that you can get out there, quadcopters especially, if there's any kind of wind, you can't fly in it. So I also wanted something that you could take off and land vertically, something that you could easily throw a BeagleBone Black on, something that had space for an XB radio, and space for an alpha adapter, and most importantly for me, that you could afford it. Right? And this is the one I chose. I actually brought this last year. I didn't bring it back this year because last year, GERCON, by the way, is the only conference where I've ever brought this drone. It's also the only conference where someone broke it. Not at GERCON, okay? It wasn't any of you. It was one of my students that I drove out here in my van last year. So they were nice enough to break it. Which was, by the way, the most anticlimactic demo fail ever. Thankfully not actually in my talk, but someone asked me to see it later, and I was out in the lobby. I'm like, yeah, this just looks like this, and I went and throttled it up, and absolutely nothing happened. And nothing happened because the wires that powered the motors broke. But all the controllers were testing out, right? Because everything else had power, just not the motors. Look, they're kind of important. But, all right, so you know, I chose the quad shot. Any of you familiar with quad shot? It's a nice little RC plane. You can buy them. They're about $400. And you can fly them in considerable wind because you can fly them as an airplane, or you can fly them like a quadcopter. You take them off and land them vertically. Flying it as an airplane is pretty efficient, so you can get some good flight time out of it. Some of the models actually come with XB radios already, and it's got a built-in camera mount if you want to see your spectacular crashes and who you're pwning, things like that. All right. A little bit about the deck. The deck I originally developed for the BeagleBoard XM. I then ported it to run originally on the BeagleBone and then the BeagleBone Black. One thing I will say about it, it's optimized for the Beagles. It's not some halfway, that's the PG version, port of a desktop distro. I won't say what distro, but there is a distro out there that's kind of popular, and if you look at their page where they talk about porting for the BeagleBoard and for the Raspberry Pi, they say right at the top, yeah, you probably don't want to run this, it's going to suck. But we just did it because these boards are cheap. So, I started with something to run on these boards. I didn't kind of try to reverse something later. Other thing about the deck, I'm up over 6,000 packages in it now, so it's probably in there if you want it. The image is around 12 gigabytes for the root file system. It's based on Ubuntu, because Ubuntu gives you some nice, good repository support, and it's running the latest kernels and all that. So what can you do with it? Well, if you just have one, you can do everyone's favorite exploit, right? MS-08-067, you can run up. You know, here, I know it's kind of hard to see from the picture, but you can run up Nmap and you see, ooh, port 445, you get all excited. And sure enough, you run up Metasploit and bam, you know, you got an interpreter shell. No surprise. Got all kinds of wireless cracking tools. So here's a little wireless crack, password cracking tools, WPS cracking if you want to use Reaver, that's in there. You can use Metasploit. This is what I call pwning Windows 7 like it's a Mac, using that Java exploit that affected all the Macs and all the Windows PCs. Nobody really talked about that part though, right? They're like 800,000 Macs owned, right? Yeah, and maybe a couple PCs too, but yeah, that happens all the time. So nobody cares about that. Also ported a few ClickKitty tools. ClickKitty is trademark me and Aaron Vinix-Vinin. A ClickKitty is a little lower than a ScriptKitty because they can only click. They can't type and use the scripts they downloaded. They can only download GUI applications. All right. So this is a screenshot from Fern Wireless Cracker. That's in there too. All right, enough about that. So here's where it starts to get good. You can take these devices, they're cheap, they're small, they're low power, so you can start taking a bunch of them, right? You can buy a dozen of these things, spend a lot less than you would spend for one laptop, and just have at it, right? You can have some serious pen testing hardware for not a lot of money. For example, I, in the book, went through an extensive pen test scenario, and the total cost for the hardware to do that pen test was $499. So for less than 500 bucks, you can just hone the crap out of stuff, right? So we'll talk a little bit about how this works, a couple of cases, and then we'll get into the real fun stuff using Python to automate this. All right, so what is 802.15 for anyway? You guys are probably familiar with 802.11. 802.11 is what? Wi-Fi. What about 802.15? Wireless personal area networks. You ever heard of those? Bluetooth, also known as 802.15.1. XB is similar. You find it a lot in industrial settings. You'll see it in low-power embedded systems. Even things like there's a possibility that these temperature controllers in these rooms are based on XB. You see that sort of stuff a lot. But as a developer, you can buy little XB radios from Digi. They come in two varieties. They have the regular ones that are good for about 300 feet, and the pro ones that are good for 1 or 2 miles. Right? They have two different modes of operation. They have this really simple mode called AT mode, or transparent mode, where it looks just like a wireless serial connection between two modems, or you can go kick it into an API mode where you have to program it and it's using packets, and that's probably what you want. Fairly low speed, but very flexible. You can set it up in a peer-to-peer network, star network, mesh network. Lots of different options available. This is just a partial shot of the devices available from Digi. They're available in different frequency ranges. I use the ones that are 2.4 gigahertz range. They have them all different ranges. Some of these will go as much as 30 miles. Right? But they're not so low power to go 30 miles, and they're not legal in every country. So if you travel around a lot, and you go from, if you're doing pen testing in Europe, you might be illegal. You can decide what you want to do about that. It's kind of like my alpha adapters have visited Bulgaria. I've never been there, but they've been there. Why would my alpha adapters visit Bulgaria? Does anybody know? You can crank it up to a watt in Bulgaria. So it's been there. I've never been there, but my alpha have. Or maybe I shouldn't. Oh, this is getting recorded. No, forget that. All right. The modems, they look kind of like this, and they have this weird metric 2mm pin spacing instead of the standard 0.1-inch spacings, which is kind of a hassle. That means that you likely have to have some sort of an adapter to use them. They both fit in the same socket if they're pro or regular. Just the pro ones are a little bit bigger and they consume more power. There are different series of XBs. There's what they call Series 1, which is the super simple ones. Series 1 XBs are pretty much good for star networks or peer-to-peer networks. Series 2 are good for mesh networks. Now, the thing that's kind of cool as a user of this stuff, like if you use the DAC and the mesh DAC extension, it doesn't matter to the code if you're using a Series 2, Series 1. Once you've set up the modems, your software doesn't care. It doesn't know. Even when you have a mesh network set up or you have a star network set up, all of the drones out there on their side, they're like children, right? Why do I say they're like children? They think they're the only thing that exists in the universe, right? It's just me talking to my parent and nobody else, right? I have no siblings. Nobody else is out there. They don't know anything about anybody else. And they don't have to. One advantage, if you have a smaller pen test, you can use the Series 1 adapters. They're very simple. They just work out of the box. Maybe you configure a couple of things and you're done. The Series 2 adapters, you have to set them up. Tell them, hey, you're a router, you're a coordinator, you're an end device, things like that. So there's a little bit more setup for those. Real simple case, you can actually set these things up between two systems, and you can use the software that's provided by Digi. It's called XCTU. You can also use Multisenso Network Manager Iron as another alternative if you want to run a native Linux or Mac app. Digi also did, over the last year, release a Mac version of XCTU. So if you're a Mac person, you can use that as well. All right. So just to review real quickly, how do you set those things up? You get your XB modem that I showed you the pictures, and I have a couple over a table as well. You just put it in your adapter, and you run the software, and you set up a couple of things. Like, you have to set up the baud rate. You have to set up things like, what's its address going to be? Every XB modem has what we call a PAN ID, a Personal Area Network ID. It defaults to 3332, but you can get cute, and you can make it 1337, or 31337 works too, you know, if you're extra elite. Or you could just leave it. And then you can use the full 64-bit addressing. 64-bit addressing basically means give me the MAC address every time you want to talk to somebody. That's probably not what you want. They have a 16-bit addressing scheme, and that's pretty simple to use. You just set your address. You set your my address to a certain number. I recommend nice numbers that are easy to remember, like your controller, that's the center for your star, that's your control station. Set it to maybe 0, and set everyone else to 1, 2, 3, etc. And once you've set that, you can set it to API mode, or that's transparent mode, save it, and you're good to go. Right? And a couple of screenshots, what it looks like. Okay. So if you just want to talk to one drone, you know, I just gave Jason Street a little system I built for him recently, gave it to him this morning. So he has a XB radio on his little Jimi Hendrix lunchbox pen testing system, right? It's got a couple alpha adapters and all that, so you can also remote it from a mile or two away. And on that system, you could just set it up, since there's only one drone, to work in transparent mode and then use TTY, right? And you guys know what TTY is? Some of you probably don't know, but basically telnet. So you can telnet into your box. I mean, you can still do SSH into it, but it's real simple. It works. All you need is a terminal program on the one end, a little bit of setup on the drone. In order to set up on the drone, you just create a file, put this stuff in it, reboot, and you're good to go, right? You can do that, but it's probably not the best idea. You can also still stay in transparent mode. You can talk to multiple drones one at a time. And the way you do this is you do the exact same thing. The only difference is when you want to switch between drones on your command console, you just wake up your modem and tell it to start talking to somebody else. So here I have the instructions and the process for doing that. Basically, you send it a couple of plus signs, you wait, and then you send it a new destination, low address, you write it, you exit the command line, and you're good to go. The command function, I should say. Okay. What you probably should do is talk to multiple drones simultaneously using the API mode. And why you want to do this, a couple of reasons. You're going to get better performance, and it's not so much of a pain in the butt, right? If you want to switch between drones, you're like plus, 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 wait, okay. ATD, blah, blah, blah. And then if you fat finger it, what do? Swear a lot, and then type it again, and if you wait too long, it gets out of the command mode, and it's kind of a pain in the butt. The other thing that's nice about the API mode is it puts everything in packets. So if you don't have a well-formed packet, it's not going to come across. Right? Which, by the way, here's a little tip. Don't screw it up. Right? Don't put one modem in API mode and the other one not. Because all the little blinky lights will go, and you're like, I'm getting transmission, I'm getting transmission. And you're like, why isn't it working? Well, it's because it says, oh, that wasn't in a packet. Drop, drop, drop. So it never gets to the drone. All right, so, and again, you do the same thing. You use the XCTU or iron in order to configure your modems, and then you put it into API mode. If you're using a Series 2 adapter, you have to tell it what it is and have to load up the firmware, which you can also do in this XCTU software. So what you do there is you have to have one coordinator device in every network. I recommend that your command console is the coordinator. And then every drone can either be a router or it can be an end device. Right? The advantage of it being an end device is that it can go to sleep. Right? Routers, coordinators don't get to sleep. So if you want to save power, it's nice to configure stuff as an end device when you can. Right? And then as far as talking to it, there's a couple of choices. You can use Java. If you don't like yourself, you can use raw commands, or you can use Python, which is what I use. Right? Okay. And when you have multiple drones, really, again, it's like talking to children. Right? They all think they're the center of the universe, and it's just them. So they don't know about the other drones. All right, so I did come up with some Python, and I call my distribution / device the deck, and some of you probably know where that comes from. And this is called the mesh deck extension, right? So what you have is on all the drones, you have a really simple Python script that just sits there waiting for commands. And when it gets a command sent, it doesn't. It sends back the output. Also, the drones are capable of sending files and sending announcements. So let's say I task a drone with, hey, go crack the wireless, or go crack this router password. It can send an announcement back saying, hey, I did it. Dad, I did it. Dad, 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 right? So all of that's in the mesh deck. One downside of this over the transparent mode is you can't run interactive programs. But unless you're a click kitty, you probably don't need that anyway, right? And as I said, there's no software changes if you want to go to a pure actual mesh network. The nice thing about mesh networks is XB, or more technically Zigbee networks, will heal themselves, change themselves dynamically. So if you're within range with all your devices, it pretty much will just work. Other things you can do with Series 2 Zigbee networking, you can do things like, well, doing a pen test from a mile away is really cool, but there's a better hotel a mile and a half or 2 miles away. So I want to do my pen test by their pool because it's better, or maybe the people there are more attractive. I don't know. So hopefully it doesn't distract from your pen test. But if it does, here's another advantage, right? Your drones keep running, even if you're distracted, or sleeping, or eating, or whatever. We won't extrapolate that too much. So with the Series 2 adapters, you can even do things like take some of these devices, and you don't need a BeagleBone attached to them, just a battery, configure it, and drop them kind of like breadcrumbs between you and the target. And that will extend your range. So then you can have your command console by the pool at the nice hotel, and then somewhere along the way between you and the target, you have 1 or 2 or however many little breadcrumbs you drop that are running routers, XB routers, and then ultimately a dozen drones just slamming your target. Right? So you can do that kind of stuff with Series 2 stuff. All right. So again, you have to have at least one coordinator. You should probably use the one on your laptop that you're controlling this with. And you can use it to extend the range and have a little bit more flexibility. Again, you don't have to change any of the code, right? You can have a small bag with a dozen of these things in it and a couple of different XB modems, and you can just configure it and go out with that one bag and do an awful lot of pen testing. You don't have to go get new devices or anything like that. Right? Okay. Real quickly, building drones is a lot of fun. Pretty much you can just get your BeagleBone and maybe get an XB cape. Logic Systems sells an XB cape. I made my own. I have a couple boards. If people are interested later, let me know if you want to make your own. Getting the software, this is important. I actually had somebody today on Twitter, he's like, hey Phil, can I get an updated version of the deck? I'm like, sure. And I said, you can get it off of SourceForge, or you can get it off of this link over at Bloomsburg University. And I don't know what, for some reason, he tried to go somewhere in Iowa. And he's like, yeah, this link used to be dead. I'm like, yeah, probably because I moved. But all right. So once you have that, it's a pretty big archive. You're going to need a 16 gig or bigger SD card. You just run a simple script, sets up the card, you put it in your BeagleBone, you're good to go. Right? You might want some power. If you're going to power your drone off of a battery, here's a very super simple power supply. You just have a 7805 chip, a couple capacitors, hook up your battery, and you're done. A little bit more on power options. You got plug-in adapters. Like I have some on the table. I like the ones, if you travel a lot, that have the click-off connectors. So if you go to Europe, you just click on a new connector, or go to UK, another connector. That's on the top. The white cable is just a USB cable. It's a standard 2.1 by 5.5 millimeter barrel connector that you see on a lot of stuff. The guys on the sides are power supplies. On the top, those are power supplies that run off of 9-volt batteries. And then the one at the bottom has got AA's. Right? And the chart tells you about how long you can run a drone that's running wireless as well, based on the battery size. So if you have 3 or 4 D cells, you can run this thing for essentially 2 days, which isn't bad. As I said earlier, if you want to, you can actually extend that potentially indefinitely using solar, but it depends on where you are at. If you're in California, you're probably going to have a lot better luck than, let's say, you live in Toronto. Pick on the Canadians. Blame Canada, exactly. Oh, what movie was that from? South Park? Okay, all right. This is just an example of the cape I designed. As I said, I do have a couple boards. Let me know later if you're interested. The design for that is open source. It's also in the book. But, I had a few made up. If you really, really want to do it yourself, these are mini capes. They have nothing but the bare essentials to connect an XP radio onto a BeagleBone. I was trying to show you just how crappy you can have this stuff look, and it still works. All right? I think I might have gone a little overboard because these look pretty bad. But now, these, I mentioned I went to Belgium a couple weeks ago. On my way over, I tested all of these before I left. I didn't test them since I got back. They actually physically broke a couple of them, the TSA did. I don't know what they were doing. They're like, oh, wow, that's a threatening board. There's nothing on it but connectors. Looks dangerous. Let's break it. All right. And no. I did get a love note on my way to Belgium, but not on the way back. I know they were in there on the way back because they broke stuff. But so this is, again, if you want to be adventurous, I would liken this to running Gentoo Linux. Anyone ever run Gentoo Linux? Right? Gentoo Linux is awesome and it's very educational. Right? So this is just a couple of pictures of making your own circuit boards. Right? So you print out a mask on transparency with a laser printer. You shine the light on to your pre-sensitized board. You develop it, and you get something that's kind of like this. Right? This looks a lot nicer than the finished board because of the soldering and how that went. But other options, you can, if you look on the table, you'll see I have a couple of devices where I just took some pegboard, a couple connectors, and soldered on someone else's serial to XB adapter. You might also need to buy at least one USB adapter to hook it up to your laptop, unless you want to, bust into your laptop and start soldering. Most of you probably don't want to do that. So there's several of these USB adapters out there. It's pretty simple to wire. You're looking at 4 wires. 2 signal wires, power, ground. That's about it. Or if you have like an XB cape, like Logic Systems, they sell XB cape. Theirs does not have the EEPROM on it that identifies it. So you have to manually say, this is what I am, and please load stuff, Ubuntu or whatever, which can be a little bit of a pain. If you have an XB cape with a properly formatted EEPROM on it, in theory, you just plug it in and it goes, oh, I see that you're an XB cape, and it loads itself. Okay. If you have a mini cape or a Logic Systems cape, you're going to have to tell it, hey, by the way, use these pins, please. And here's how you do that. You have to, as root, echo BBUART2 to this file location. And by the way, this might be CapeManager.9, depending on the version of the software you're running. And you put this into an rc.local file, and it will just start up that routine to run and listen for commands. But before it does that, it'll say, hey, by the way, I wanted to use these pins. So please set it up as this UART. And as I said, you can have an XB cape. I'm also working on some more advanced capes, like what I call the ultra ponage cape, that has the XB socket, it has wireless, it has a wired hub or switch, and maybe some other stuff. So, still working on that one. Also, I showed you guys last year the aerial deck, the air drone, and I want to take the built-in board that Transition Robotics has and pull that out and just replace the entire thing with a BeagleBone because it's more powerful and flexible, things like that. Okay, and of course you got to put your stuff in cool little containers that your kids are after you for. This is the system I made for Jason. You can't see the Jimi Hendrix lunchbox, but that's what it's in. And of course, you can take these and plan them. This is a network switch on top of a BeagleBone. So if you had a desktop system, you can take it, slap it on the back of someone's desktop, leech power from their USB ports, connect their networking inline to the network switch, and you'll probably be there for years till the next time they clean under their desk. Okay. If you need wireless, you can do something similar. This is the same picture, just with a expanded view. Air deck we talked about last year, and I kind of went through. I'm just going to quickly go through this. How you put it together. This version of the air deck is entirely installed on the lid that covers the bringing box. That's what they call it for the drone. So you put it together and fly it away. I will say this, practice flying it before you put that on there, because it does change the flight characteristics. These things are not the easiest to fly. Right? I'm a pilot, I have a dozen ratings, I have thousands of hours of flight time. I suck at flying this thing. Right? So maybe it's just me, I don't know, but I would recommend practice. Okay, so a little bit about networked attacks. Simple case, you have one drone, you put it out there. Why do you want it? Because you're not sitting in the parking lot looking suspicious in your panel van, right? You can actually go do something else. It's running, right? If you have biological needs or, whatever, you can leave and it's still going. Where you really get the power, though, is when you start using multiple drones. And real briefly, the way that I have it set up is you have on your command console, your laptop, you run the software, and it just says, hey, what drone do you want to talk to? And it defaults to 1. If you want to change the drone, you just say : and then the drone number, and it switches to that drone. And when you run a command for a drone, the output is sent back to you. It's put in a log file, and then it's displayed with a highly advanced utility, which I didn't write. It's called Tail. Anyone heard of it? So literally, all I'm doing here, it's nothing fancy, but it works, is basically, oh, there was a response back from this drone. Let me open a terminal window, and let me tail -f the file, and it scrolls along. Right? Hey, it works. Does that make me a click kid? No. I'm at least a script kiddie, so that's not a GUI tool. But anyway, so here's a couple of examples. You go out and you're like, oh, look, I see some stuff running, and I think I might know what it is, and I can go in and I can, do some ponage. A couple of scenarios with the air deck of the aerial drone. Depending on the situation, I will admit that it's the case where every single pen test, you're not going to need this air drone, right? But when you need it, right? Besides, it's kind of cool, especially if you can expense it. Well, yeah, I had to build a RC drone. I need $500. No. All right. And if you crash it a lot, it's good to be able to expense it. Okay. By the way, just so you guys know, you can buy just the airframe. It's $100. So when I bought mine, I bought a spare airframe from the start. I'm like, it's going to crash. Just assume it's going to crash. So a couple of scenarios, you might have just the air deck. You can fly it in, hack away. You could have the air deck combining with other drones. You might have the air deck with one of those more powerful XB adapters on it, right? So it's going to do a lot of the heavy lifting and getting those signals back to your command console. All right. So let's talk a little bit about automating with Python. So this is not going to be rocket science, just so you know, in terms of the Python, but this is real simple stuff you can do with Python to make this a lot more automated. So what's the first thing you're going to want to do? Detect wireless networks. What wireless networks are there, right? So this is a pretty small Python script. I don't know. If you take out the comments, there's probably, what, 10, 12 lines of code here that's going to use Scapy. Anyone familiar with Scapy? Yeah. It's a pretty nice little library for Python. And all it does is it creates a variable for storing access points that it's seen and defines a packet handler, starts a sniffer function for Python or for Scapy, sniffs for a minute, and then exits and gives you a list of all the networks it saw. Pretty basic. Right? If you want to capture packets, Scapy will do that too. So you can do that by, again, from Scapy, you have to import everything. Also using this opt-parse library. You guys familiar with opt-parse? Who's read T.J. O'Connor's Violet Python book? Right, so you should be familiar with opt-parse because I know he likes it. You know, he uses it a lot. All that does is parses command line options. Very similar. You create a client list, create a packet list. Initially, they're empty. Right? Define a packet handler. And you say, hey, is this a .11 packet? If it is, append it to my list of packets. Right? Is this a client that I've seen before? If it's not in the client list, I'm still going to, I've always appended the packet. By the way, why do I always append the packet to my list? There's a real good reason, right? This is a packet handler. Right? You want it to run and run fast, right? So you don't want to be, well, do I really need to look at this packet? You don't want to be doing that, right? Because what happens while you're deciding if you really need that packet or not? The next packet comes in. And if you're cracking Wi-Fi, that next packet might have been what? That other handshake packet that you really needed to crack WPA2, right? So that's why I just capture all of it. But I do ask, hey, if I've seen this client before, and if not, I add it to my list. Right? And here's the main function, basically just parsing out some arguments. Oh, that's interesting. Okay. I got a dual screen. I'm like, okay, I'm like circling stuff with my mouse, but you don't see that. Apologize. And you can set it to just one BSS ID and one ESS ID. It's pretty much just going to sniff these packets, and it's going to write them using this PCAP writer function. So it'll write them as a nice PCAP file that everything in the world knows how to look at, right? Wireshark, all those aircraft tools know how to deal with PCAP. And this is a little thing that some of you that have used Python probably know about. A little trick, you can say if __name __ equals underscore underscore main underscore underscore, then just run something. So if you just run the script, it'll run properly from the command line. Okay. Once you've figured out what networks are there, you've captured some packets. Hopefully you captured some handshakes, and you cracked the wireless. Now you want to say, what's out there? So what's the go-to tool for that? Pretty much Nmap, right? So is there an Nmap Python module? Do you even have to ask? Of course there's an Nmap Python module, because everyone loves Python in this business, and people like Nmap. So what you can do, this is a pretty simple script. This one, it's 2 screens long. Again, in the main function, you're going to parse a couple of options, some Nmap options. Maybe you just want to target one thing or a network. What ports do you want to target if you want to choose specific ports, and also any particular Nmap options you might want to use. So once you've done that, you take your command line arguments, you parse them, set them to some local variables, and if you didn't do it right, you print out a little message saying, sorry, here's how you should use this tool, and you exit. Otherwise, you create a port scanner with Nmap, and you verify that the arguments are correct. Like if they didn't give you ports, then you default to 1 through 1024, and you run your Nmap scan. You get the results, and basically you have to wait and see, when is it done. There's different ways of running Nmap in this. You can run it synchronous or asynchronous. Once that's done, you take all those results, you print them out in a nice, neat way. But the other thing that I think is very useful, I'm taking the results and storing it in a JSON file. Right? You guys familiar with JSON files? Right? Who loves JSON files? Web developers really love JSON files. And the rest of us like them too. Right? So you store that stuff in a JSON file. And why would you want to do that? Well, because then you can take that and you can feed it into the next script. Right? So the next script is going to take stuff from that JSON file, and then it's going to use OpenVAS. Right? So it's going to parse through that. Now, how many of you used OpenVAS before? Okay. It's a decent tool. One thing, if you've ever used it, you probably already know. You do not say something like, hey, let's do a scan 192.168.1.0/24 with OpenVAS. Because guess what it's going to do? The first thing it's going to do, it's going to repeat that entire port scan that you just did with Nmap. It's going to take freaking forever, because it's a lot slower than Nmap because of the way it does port scanning, right? Because it's like, well, is there something there? Is it really there? I think it might be there. Maybe it's vulnerable. I just don't see it. Let me try again. Okay. So it takes forever, and that's another reason why, again, taking those results from the previous Python script, pumping them into the next Python script is really helpful, right? So, this will connect to an OpenVAS server. It'll run through those things, and it'll do a scan. All these scripts, by the way, I have available online, so don't worry about trying to take pictures or something of these. So here again, the way this works is it'll start the scan, it'll start the task, which I'm doing here, and then it's going to keep checking and say, am I done yet? Right? Because it's an asynchronous call. It doesn't know if it's done yet. And I have a nice little, kind of sleep in there, because you don't want it in a nice tight loop. That's not good for anybody. And now you know what's vulnerable. All right? So you found out what's out there. You found out the network. You cracked it. You found out what was there. You found out what was vulnerable. Now what's it time for? Let's exploit some stuff. All right? I'm sure some of you have heard of this little tool, Metasploit. Anyone heard of it? Yeah. So some of you are probably more familiar with using Metasploit as the Metasploit console. You can do all the same stuff with the command line interface. Also, I think in a lot of ways the command line interface is faster because it doesn't load quite as much stuff every time you run something. General format is like this. You just run it. You give it the name of the exploit, the platform, which is usually Windows, the type of exploit, is it SMB, is it something else, the name of the exploit, MS-08, 067 maybe. You give it your remote host address, a payload, any optional stuff you want to set, and it'll run the exploit. Then you execute the exploit. Give it an X. Please run this. And once you've done that, hopefully you get a shell, right? Some other stuff that I'm working on at the moment with this whole platform, continue to add new stuff. The original version of the deck had only 1,600 packages. The current version has 6,000, right? Including a lot of Python libraries. Some more optimization. I'm working on some more optimization for the Beagle platform. It's already somewhat optimized. Looking at some other output devices. Also, in a couple years back, I did some work with USB stuff and looking at repeating some of that with the Beagle boards and exploiting some of the USB on the go functionality of those boards. As I mentioned earlier, taking that Laia board out of the drone, out of the air drone, and replacing it with a BeagleBone Black. And also I've been doing a little bit of work using gateways. So I said you can use a bunch of breadcrumb routers to extend your range. You can also get these lovely XB gateway devices, right? So how could you use that? A real simple way to use that, you just take it, you put it in the proximity of your target, hopefully by someone's open Wi-Fi, right? So you connect to their open Wi-Fi, you connect to the XB drones, right? And then you don't have to be a couple miles away. You could be in another country, except Canada, because who would want to go there, right? So that's something else that I've been working on, right? And I know we started late, but we're also getting close to party time. So I'm going to wrap it up and just tell you, all the answers to all your questions and more. There's a book out there. Also, if you have any questions, feel free to track me down. I'll be around till tomorrow sometime, and thanks a lot. Bye.